day, everyone. Trust that you are doing fine. Welcome back to physics class today. Today we are looking at a topic called static electricity. When you hear the word static electricity, we are talking about electricity that is not moving. The word static means not moving, stationary. Okay? So in this topic, we look at charges. Basically, we have two types of charges. We have positive charge, we have negative charge. When you have positive charge and negative charge closer to each other, nearby, if you look closely, you see these lines that are drawn with arrow. We call those lines electric field. Electric field. Now, for positive charge, electric field will leave positive charge as in it comes out, but for negative charge, electric field enter negative charge. So when you have positive and negative charge nearby, there is what is called attraction, because the electric line of force, which electric field lines, leave positive and enter negative charge. Okay, so there is connection, and that's why we say there is attraction for all like charges. Don't forget, positive and negative, they are online. On the other hand, when you have like charges, meaning that positive and negative, but in this case we're using two positive charges, which is like charges, the line of force, which is electric field lines, leave two of them. So there is no connection such that the midway between them, there is no line of force there. Of course, that place we refer to as a neutral point. It's called neutral point. Neutral point is a point between like charges where the resultant field is zero. Is that okay? Don't forget. Alright, so that's about charges. Now, how do we charge an object? Before you charge any object, look at the marker I'm holding in my hand. Right now, they are not charged, so we refer to that as a neutral body. A neutral body is simply referred as, as a body that has equal number of positive and negative charges. So let's make reference to what I have on the board. I have this neutral body on the board, and if you look closely, I have 5 positive charges and I have 5 negative charges. So this is referred to as a neutral body. Now I want to charge this object. Now the process of charging is called electrostatic induction. So what I will do is I will bring nearby a charged object. So this object is being charged negatively. So it's brought closer to this neutral body. Immediately this charged body is brought nearby, the charges within this neutral body, they will all rearrange themselves, okay? So that you are going to have the opposite charges, which in this case, we have positive charge. They will move very close, they will rearrange, they will move very close to the charged body, which is negative charge, and the negative charge will move further away, meaning that the positive ones are attracted, negative is being repelled. Don't forget, we said that some minutes ago on this part of the board, alright? So, but while you are doing that, the charge object is still in position. You don't take it away. So what will happen is that because those charges they are rearranged. Now you must find a way of earthing the object, the body. I mean, everything has to do with a way, you create a pathway for this object to be connected to the ground level. So in that case, because you still have this there, this charge body will attract the positive charge, and this negative one being repelled, they will have a pathway to move to the ground. Alright? So this one will move to the ground through this earthing wire. This symbol represents earthing. Earthing means a way, a connection between an object into the ground, so that charges can move to the ground. Okay? So while that is done, this one will move away, and you're going to have, of course, while this one have gone, you take away the charge body, so you're going to have the object being positively charged. Okay, so that's how to charge an object. Don't forget, it's very simple. Alright, so let's look at, basically in this topic, we have two types of objects. We call one insulator, the other one is a conductor. When you hear the word insulator, insulator simply means an object that has its electrons, its atoms, bounded together. They can't move. They are not able to move, so that's why they are not able to conduct. Example of such is a plank, a wood table. The second types of object or body is called conductors. Conductors allow charges to flow through them. Their electrons are free, they are not bounded, okay? So, such things like a metal, even you, me, I'm a conductor. You ask me how, you ask me why. The reason is simply because I have salt water within my body. That's why when you make a mistake, you know, you touch a live wire, the currents from that live wire will pass through your body, and of course, they move through to the ground. The ground is considered to be at a zero voltage, okay, zero potential. So they move to the ground, and because our body, by virtue of you know, the cells, the brain, we are not designed to conduct electricity for so it's a bit harmful. So don't risk it, okay? But basically, you are a conductor, and I'll show you the reason. All right. So quickly, as round up, we look at dangers of static electricity. Dangers are so many. I'm sure you will observe in different part of the world, in Nigeria, for example, anytime it's about to rain, you observe what is the lightning effect. That lightning effect has to do with charges in the sky interacting. And once they interact in the sky, there is a reaction, and the effect is that the charges will create, the cloud will be charged. And of course, at that time, the air is charged. So you don't expose yourself. Let me tell you, maybe I don't know, maybe you will have heard this or observed. At such a time, you're not supposed to be outside the house, you're supposed to be indoor. Because any metal object outside that you step on, you can be electrocuted. Even your houses, the window of the house, if at that time you expose yourself to go and touch any conductor at the window, you can conduct charges. And of course, sometimes people will say, oh, it's the enemy. It's not any enemy, it's purely science. So don't like thing. Another one is when they are refueling aircraft. You know, there is dust in the air. Within those dust, there are charges there. So when they are refueling aircraft, okay, there is possibility of the body of the aircraft to have been charged, all right, and that can actually cause fire outbreak. So what they do is that the tire of the aircraft conduct away those charges. Just like I told you about the heat effect, it conducts the charges away. Is that okay? So as to minimize the danger that may happen. Of course, you can consult your test for other dangers. When you talk about uses, we can use this sensitivity in so many ways. I can tell you we have what we call dust precipitator, and we also have in the photocopier, you know, photocopy machine that you see everywhere. There's a drum inside it that creates static charges that the ink is going to be attracted to, or you know, kind of, of course, it will be very hot. Then it's going to get itself attached to it, and that is what enables our papers or whatever you're photocopying to be duplicated. Okay, so these are some of those things we do. I trust and I believe you listen to this again and again, and you consult your textbooks. Any question, clarification, feel free to let me know, and I trust that you'll be fine. So thank you very much. We'll see you some other time. Have a nice day.